everyone, my name is Miss Connolly. I started making videos for my 5th graders and this one is for them again. I wanted to reach as many students as possible during this crazy time, so please make sure you share it with somebody else so we can get as many students ready for the next grade level as possible. So today we're going to be talking more about dividing when there's decimals involved. So a couple of videos you need to watch before you watch this one to make sure you understand. The introduction to dividing by powers of 10, division when there is a decimal in the divisor, division when there is a decimal in the dividend, and now we are tackling another situation when there is a decimal point involved in the dividend and in the divisor. What do we do? Also important to know the multiplication of decimal videos. There's a playlist for it. Also will help you in figuring out what to do here. All right, so strategies already taught. When we are dividing with decimals, we are thinking about making an estimate first. This is going to help us determine what to do with our quotient. Okay, where does the decimal point go? Does our quotient need to get 10 times larger? Does our quotient need to get 10 times smaller? Does it need to do both? Like today, we'll see. Also, I want you double checking with multiplication once you get your answer. And last but not least, we are using whole number division strategies when we're solving. Okay, I'm going to go through all of that, so let's get started. So the first things first, let's give it a story problem context. There is 67 5/10 miles. I have 4 5/10 hours to do this. How many miles do I have to run each hour in order to finish? Okay, I'm not that fast of a runner, but if I was, let's just pretend. All right, so what we need to do first is we need to make an estimate. All right, so with estimating comes rounding. So you can choose if you want to round the dividend and the divisor, or just the dividend, or just the divisor. And you can choose how you want to round those. Remember, we just want to get as close to an accurate estimate as possible. So I am going to do some rounding. I am going to say 67 5/10 is close to 70. Okay? I'm going to think that 4 5/10 is close to the whole number 5. I wanted to deal with whole numbers. I like dealing with whole numbers, so that's where I went. Okay? I also decided to round some nearest 10 because I knew over here I was going to be dealing with the number 5, so I thought that that would just be easier for me. So when I think about 70 divided by 5, I know 50 divided by 5 is 10. I know 20 divided by 5 is 4. So my estimate in this situation is going to be 14. Okay? So I'm going to be thinking about trying to make my quotient, well, not trying, I'm going to make my quotient, but then I'm going to choose where to put the decimal point to make it a reasonable with my estimate. Okay? So I'm going to put my estimate, I'm going to put it down here in the corner so it's out of the way. That's my estimate, and we're going to get started. Okay? So what we want to do here is we want to be thinking about using whole numbers to help us solve. So I'm going to be thinking about 675. I'm going to pretend the decimal point's not there while I'm calculating. And I'm going to be thinking about 45. Again, thinking about the decimal point not being there while I'm calculating. Okay? So there are several different ways that you can get to solving. I'm going to do the one that's most familiar to my students when we're talking about whole number division. But if you have another strategy that you find to be more efficient, then use it, okay? So when I'm thinking about dividing, this is not necessarily how to divide with whole number lessons, so I'm going to get through it quite quickly. There is a division video currently out there in the 4th grade playlist. If you want to check that out, it's 4-digit divided by 1-digit, and soon we'll have 4-digit divided by 2-digit, but the same strategy is used each time, okay? So I'm thinking about making 45 groups of 10. That's 450. I know this is half of 450, so I know that I'm going to half my factor. Just adding in anything extra I can teach you while I'm doing this quickly. Okay, and let me just double check, 225. Yes, we're good. So when I am thinking about dividing with whole numbers, 675 divided by 15, or sorry, divided by 45 is the whole number 15. All right, so let's head back to my estimate, and I'm going to show you why the estimating for me and thinking about what is the reasonable answer is the best strategy in these situations, because there's a lot of other stuff to keep track of. So my estimate was 14. My whole number answer is 15. Well, this is crazy because there's all this decimals involved. How are we getting almost this? Would we keep our answer the same? Would our quotient for 67 and 5/10 divided by 4 and 5/10 be 15 if 675 divided by 45 is also 15? What do you think? My estimate was 14. So let's talk about what's going on, okay? You learned in the first video that when your divisor, which is this number here, gets 10 times smaller, which it did, your quotient would get 10 times larger, okay? So if we were doing 675 divided by 4 and 5/10, notice there's no decimal here right now, it would be 150 because the pieces got 10 times smaller and you need 10 times more of them. But then you also learned in the next video that when your dividend gets 10 times smaller, so 675 divided by 10, that your quotient gets 10 times smaller. You put a decimal there, okay? So I'll just do it like that. So 150 divided by 10 is 15, and then you see where the decimal came in if you were thinking about it that way. So what you're saying is, if the divisor gets 10 times smaller, our quotient gets 10 times larger. But then, if our dividend gets 10 times smaller, the quotient goes back to 10 times smaller. Interesting. So the relationship between these numbers kind of stayed the same because I divided the dividend and I divided the divisor both by 10. We end up with the same quotient, okay? Now, this is going to be a lot to keep track of, especially when we get to the third example today, because one thing's going to get 100 times smaller, the other's going to get 10 times smaller, and it's like, oh, what do I do? So, what's important for you to remember is that your estimate is going to help you a ton. You are going to be thinking about what is a reasonable answer in this situation, okay? So, do not skip the estimating part, all right? Last but not least, the last thing that we're going to do is we are going to think about using multiplication to make sure that our answer makes sense. We feel more comfortable multiplying decimals, so we're just going to use that to help us. You know there's an inverse relationship between multiplication and division. So my original story problem was there's 67 and 5/10 miles that I have to run. I have 4 and 5/10 hours to do it. How many miles do I have to run each hour? And again, I'm not that fast of a runner, but whatever. So what we're going to make sure that we do is that we say I did 4 and 5/10 hours, 4 and 5/10 groups of 15 miles. Is that 67 and 5/10 miles? Okay? To check with multiplication, I just want to make sure that this all checks out. Okay? You can see that I wrote this 15 times 4 and 5/10 equals 67 and 5/10. You know that there's that relationship. I'm not going to go over it in depth. So let's see if we can, if this matches 67 and 5/10. So this is just me double checking my answer to make sure. Oops, I ran out of space, so I'm going to add it up over here. I want to make sure that I have gotten my decimal point in the correct place. If I needed to make my quotient 10 times larger, 10 times smaller, I just want to make sure everything's correct when we're working with decimals. So 4 and 5/10 times 15, I know that one factor got 10 times smaller, so my product gets 10 times smaller, and I double check. Is it correct? Yes. Do I have my decimal point in the correct place in my quotient? Yes. Okay, or did I make my quotient large enough to match what was going on? Did I have to make it 10 times greater? All those things you want to make sure are correct when you check with multiplication. Okay, so while I'm erasing, I'm going to review what happened. okay? We thought we made an estimate. We divided as if the numbers were whole numbers. We decided what we had to do with our decimal and our quotient. Did we have to put a decimal somewhere? Did we have to make it 10 times greater? Did we have to make it 10 times smaller? Based on our estimate, then we checked with multiplication to make sure we put it in the correct place. Okay? So let's try another example. Okay? So this time we're going to be thinking about 64. Wait, I gotta leave it down here so I have room for my whole numbers. 64 and 8/10 divided by 2 and 4/10. Okay? So this time, let's think about days. So I'm biking 64 and 8/10 miles. I have 2 and 4/10 day to do it. How many miles do I have to bike each day to make sure I finish on time? Okay? So what I'm thinking about is I have 2 and 4/10 groups of something, and that will equal 64 and 8/10. Okay? The first thing I want to do is make an estimate. So when I'm estimating, I'm going to do some rounding, as you know. So 64 and 8/10 is close to 65. 2 and 4/10 is close to 2. I'm going to go ahead and round this actually to 60 and not 70, but 60 because I know that I'm dealing with 2 over here and I just want to make an estimate. So 60 divided by 2 is 30. So my estimate is that my quotient will be somewhere around 30. I'm going to sneak it down here so that I have space to work. Okay? Now, in order to solve, you are going to be thinking about 648 divided by 24. Okay, we're going to use whole numbers to help us solve. Again, just putting a strategy out that we are familiar with. So when I do 648 divided by 24, I'm going to start with 24 groups of 10, which is, just kidding, 20, 30, 20, 480. Sometimes teachers need a second to think too when we're doing math on the fly. So then I have 168, and I know that I can do 24 groups of 7, 140, 28, yeah, 168. Okay, so, sorry to do that quick. Again, there's videos about division, whole number division. So, when I'm doing 648 divided by 24, my quotient is 27. Okay, so if I was biking 648 miles over 24 days, I would have to bike 27 miles each day. I'm only biking 64 and 8/10 miles over 2 and 4/10 days. Okay, so let's go down to my estimate, which I thought was going to be around 30. Okay, so I look at my whole number quotient and I say, 27, that's close to 30. That's close to my estimate. So then I ask myself, do I need to make it 10 times greater, or 100 times greater, or 10 times smaller, or 100 times smaller? Or does my answer already seem reasonable? And I'm thinking that 27 is really close to my estimate of 30, and I know I did some great rounding, so I'm pretty sure that's correct. So how are we going to make sure? Well, you know that if the dividend gets 10 times smaller, your quotient would have to get 10 times smaller. So if I did 27 divided by 10, I would be at 2 and 7/10. But then my divisor got 10 times smaller too. And I know if I did 2 and 7/10 times 10, because when your divisor gets 10 times smaller, your quotient gets 10 times larger, I'd be back at 27. So if I divide by 10 and multiply by 10, I'm back where I started. Okay? So we just want to triple check that our answer makes sense. So we're going to use multiplication to double check. But right now, I think we're sitting pretty good. Am I going to skip the double check part? No. Are you going to skip the double check part? No. Okay? So what right now I'm thinking that 2 4/10 groups of 27 will get me to 64 8/10. Okay, so let me see here. We'll do, again, you can check with any whole number strategy you want. I just think this one's easiest for me to talk while doing at the same time, so that's why I'm choosing this one. The other day I was telling a friend I need my students to help me with mental math because you're all so much better at it. So if I do 27 times 2 4/10, I know that if one factor gets 10 times smaller, my product gets 10 times smaller, and I double check. If I have my decimal in the correct place where I started, after I multiply out, I know that I did the right thing here. If your decimal ends up in the wrong place when you multiply to double check, you've made a mistake and you need to go back and fix it. All right, one last situation, which I'm so excited about because I really want to teach you how estimating is important and thinking about the size of your answer is important. So we're going to be thinking about 7 36/100 divided by 2 3/10. Okay, so I have 7 36/100 miles to run. I have 2 3/10 of an hour to do it. How many miles do I have to run each hour? Okay, so first and always first, always first, is you're going to make an estimate. Okay, I'm going to round 7 36/100. I'm going to call it 7. Okay, I'm going to deal with the whole number. 2 3/10. I'm going to be thinking about that as 2. Okay, when I divide 7 divided by 2, it could look like that when you first get started. And I'm thinking that 7/2 is the same as 3 1/2. And I know, I'm going to write my estimate down here, that 3 1/2 is close to 3 5/10. Okay, this right here is going to be the key to solving, because let's think about what's happening. We're going to use whole numbers to solve. In the last two situations, the dividend got 10 times smaller and the divisor got 10 times smaller. However, in this situation, when we're figuring out where to place the decimal, or if we need to make our quotient 10 times larger, 100 times larger, we need to look at what's going on. Our dividend got 100 times smaller. Our divisor got 10 times smaller. So this time, we're not going to be dividing by 10 and multiplying by 10 the quotient and ending up in the same place we started. Something different is happening. Okay, so this estimate down here is going to be very helpful in helping us decide what to do. So again, whole number strategies to divide. Okay, whole number strategies to divide. Okay, so I'm going to start with 23 groups of 20, and that is 460. Again, that mental math sometimes a little difficult for the old lady teachers. Okay, actually I could have done 23 times. I'll do 23 times 10 again. Sorry about that. Okay, and then I know I can fit 2 more groups of 23 in there. I should have combined those and done that in one step. It would have been more efficient. My bad. Okay, so when we think about our whole number answer, when we're dividing the whole number 736 divided by 23, our whole number answer is 32. So now we have to think about our estimate. When we know that the digits we're using are going to be 3 and 2. Sorry, the digits we're using are going to be 3 and 2. But the number 32 does not make sense with my estimate. When I'm thinking about which answer makes sense, I'm thinking that I have to put the decimal here because my estimate was 3 1/2. I was thinking about 7 divided by 2, and I knew that was 3 1/2, so I know that my answer my quotient is going to be somewhere close to that estimate. So that's how I'm choosing where to place the decimal. Okay, so if you wanted to play around with what's happening when the dividend gets 100 times smaller and the divisor gets 10 times smaller, I will show you, okay? So 736 got 100 times smaller. When our dividend gets 100 times smaller, our quotient will get 100 times smaller. So if I take 1/100th of 32, I am thinking that's 32 divided by 100. Another way to say it, I get 32 hundredths. 32 groups of 100th, 100th of 32 is 32 hundredths. Okay? Then, when my divisor got 10 times smaller, I know my quotient gets 10 times larger. So, I'm doing 32 hundredths times 10, which is the same as 10 groups of 32 hundredths. It's getting 10 times larger, which means our digits are shifting. Okay? And I end up at 3 2/10. But that's a lot of work when you can rely on your estimate, okay? You don't have to do, what was the rule again? The dividend, you have the estimate to help you, okay? What else do you have to help you? You have thinking about multiplication, okay? So what I'm gonna do is I'm gonna take 3 2/10 times 2 2/3 and make sure that I end up with 7 3600. So 3 2/10 times 2 2/3, and I want to end here. So 3 2/10 times 2 3/10 equals 7 3600 is what I'm hoping is going to happen. Just while I'm thinking about this, does it make sense that 3 groups of 2, a little bit more than 3 groups, a little bit more of 2, gets us to 7 3600? I'm thinking yes, because 3 times 2 is 6, so let's just see what happens. We're going to multiply them as if they're whole numbers, and then we'll place the decimal where it goes, and we'll make sure that we have the correct answer. So I know that one factor got 10 times smaller, so my decimal would go here, but the other factor also got 10 times smaller, so my product gets 100 times smaller. And I make sure that my quotient is correct by double checking with multiplication. We want to make sure that that works, okay? So, in all of these dividing decimal videos, I've been really trying to hammer something home, so I'm going to say it one more time. Before you start, I want you to make an estimate. This estimate will help you decide whether you need to make your quotient 10 times smaller, 10 times larger, 100 times smaller, 100 times larger. It's going to help you figure out if you need to put a decimal point somewhere, or if you need to multiply your quotient by 10 or 100 and make it greater, okay? So the estimating is really important. Then you're going to consider what's happening with your dividend and divisor, and you can rely on those rules as well, okay? You're going to divide as if you're dividing whole numbers, okay? Then once you get the whole number answer, if you were dividing whole numbers, you have to make the adjustments in the quotient so that you're close to your estimate, and you've also decided what's happening to the dividend, what's happening to the divisor, so what should be happening to my quotient. And last but not least, you are going to double check, you are going to triple check, you are going to make sure that that decimal is in the correct place, or that you've made your quotient large enough by multiplying with and putting your decimal in the correct place when you're done multiplying, because you probably feel more comfortable with that now. And you want to make sure that everything works out. Okay? So, as usual, I'm going to give you 3 to try at home. So you are going to think about, 81 in 6/10 divided by 5 in 1/10. I want to see some rounding. I want to see the estimate. Okay? Then you're going to think about 22 and 41/100 divided by 9/10. This is close to 1 whole. So you're rounding and getting an estimate first so you know where your decimal will end up, or if you need to make the quotient 10 times larger, 10 times smaller, all that jazz. And then the last one that I want you to try on your own is 70 and 4/10 divided by 3 and 2/10. Again, estimating is going to be important to help you place that decimal point also help you decide whether or not you need to make your quotient 10 times larger, 100 times larger, all that stuff. Okay? I hope this helps.